Hi everyone, today I am going to go through a couple of examples explaining the derivatives of polynomials and exponential functions. Let's have a look at the formulas that enable us to differentiate constant functions, power functions, polynomials, and exponential functions. Starting with the simplest of them all, the constant function. Derivative of any constant function is always equal to 0. Then it is the power function. The formula to differentiate power functions is called the power rule, and, in its general form, it states that, if n is any positive integer, then derivative of a power function is always n times x to the power n minus 1. The content multiple rule states that, if c is a constant and is a differentiable function, then the derivative equals c times the derivative of the differentiable function. The sum rule states that, if f and g are both differentiable, then the derivative is equal to the derivative of f plus the derivative of g. Then the difference rule states that, if f and g are both differentiable, then the derivative is equal to the derivative of f minus the derivative of g. We also need to remember that, the definition of the number e satisfies this limit. The derivative of the natural exponent function has the property that, it is its own derivative. Now, let's go through a couple of examples to apply these mentioned techniques. Starting with a square root of 120. We first add the derivative notations, then simplify, and then apply derivative of a constant rule to get our final answer of 0. Now let's do b. 1 over 2
t to the power 6
minus 3t to the power 4 plus t. We first add the derivative notations. We then differentiate summands separately and pull out constant factors. And then, apply the power rule throughout to get 3t to the power 5 minus 12t to the power 3 plus 1. Now let's do c. Square root of x minus 2 times the natural log to the power x. We first add the derivative notations. We then differentiate summands separately and pull out constant factors. This will then give us 1 over 2 times x to the power half minus 1, subtracted by 2 times natural log to the power x. And then, we get the final answer of 1 over 2 square root of x minus 2 times natural log of x. Now let's try d. Square root of t minus 1 over square root of t times t to the power 3. We first add the derivative notations. We then differentiate summands separately and pull out constant factors. Then, we apply the power rule throughout, until we get 1 over 2 times square root of t plus 1 over 2 times the square to t to the power 3. And then, we simplify further to get the final answer of t plus 1 over 2 times the square root of t to the power 3. Now let's try e. 1 over 3 times x, all to the power 3. We can first simplify this function further to avoid using the chain rule. We first add the derivative notations. We then differentiate summands separately and pull out constant factors. Then, we apply the power rule. And then, we get our final answer, 3x squared over 27. Now let's try f. Square root of 2 times square root of u plus square root of 3 times square root of u. We first add the derivative notations. We then differentiate summands separately and pull out constant factors. Then, we apply the power rule throughout, until we get 1 over square root of 2 times square root of u plus square root of 3 over 2 times square root of u. And then, we simplify to get the final answer of square root of 2 times square root of 3 plus 2 over square root of 8 times square root of u. Let's try more examples. Here, we are asked to find the first and second derivatives of the following functions. Let's do g. X to the power 4 minus 3x cubed plus 16x. We first add the derivative notations. We then differentiate summands separately and pull out constant factors. We apply the power rule and simplify to get our first derivatives, which is 4x cubed minus 9x squared plus 16. Now we need to find the second derivative. We add derivative notations again, then pull out constant factors and apply the power rule. Then we get 12x squared minus 18x, and this is our second derivative. Now, h. Square root of r plus cube root of r. We first add the derivative notations. We then differentiate summands separately and pull out constant factors. We apply the power rule and simplify to get our first derivatives, which is 1 over 2 times the square root of r plus 1 over 3 times the cube root of r squared. Now we need to find the second derivative. We add derivative notations again. Then pull out constant factors and apply the power rule. We then simplify. Then we finally get 2 over 9 times cube root of r plus 1 over 4 times the square root of r. And this is our second derivative for h. Give these ones a try. If you found this video helpful, feel free to click on the like and subscribe buttons below.